Hi guys, this is Thomas from Grown with LED. And today I want to talk to you about my newest project. It's going to be a series of light measurements. Since I'm not only an avid grower but also an electro-technical engineer, I was always interested very much in the technical data of different light fixtures. And one of the most interesting things is how much power they consume, how much energy they need for a grow. So we're going to measure actually how much power each light fixture is going to use, and we're also going to see how much light output that power brings. So we're going to measure the quantity of light that's coming out of each lamp, and we're going to do this with the BPFD, the biologically available photoflux density, which means this goes from 350 nanometers to 800 nanometers, a little more than normal PFD, because I'm very convinced that far red, which is at 730 nanometers, is very important for the growth, and most producers use it nowadays, so I'm going to measure this as well. The BPFD is going to be measured. At the end of the measurement, we want to have a light plot that you can see in an example here. A light plot shows the distribution inside the grow tent, where you can see most of the light is concentrated in the middle, while less light is on the outside of the tent. And we were going to measure some key values, which you can see here. The key values which are interesting for us are the power consumption, the BPFD sum, the average, the per watt, the maximum, the minimum, and the homogeneity and inhomogeneity of the light. We're going to measure all of this inside the Homebox Ambient Q120 Plus, which is the grow tent I have been using for years. You can see it behind me. It's a very sturdy built grow tent made in Germany, and it has an inside reflecting layer which is white, the Par Plus, which gives a more diffuse reflection, which I prefer over the silver lining of other tents. And since I've been using it for years, this is going to be a real grow environment, real life measurement, which all growers should be interested in, and I look forward to do it. For the light measurement series, we're going to hang the lamps above a specially made grid, a 10 centimeter grid, which gives us inside this 120 by 120 centimeter tent 144 measuring points. And we're going to have the lamps at water level and an equal distance to each other and to the sides, so we have a perfect light distribution above the grid. And this is what we're going to use for the measurement. And we're going to hang the lamps at the distance that is recommended by the producer of the lamp. If it's not in the manual, we're going to contact the producer to ask them what level they recommend to hang their fixtures above the plants. So it's again going to be a real life environment measurement of our light. In our light measurement series, we're also going to measure the power consumption for each light fixture with the Voltcraft Energy Logger 4000. In this display mode, it shows us how much voltage is there on. It's 234 volts at this moment. It draws a current of 1.07 amps, and this all is happening at the typical European 50 Hertz. If we go one further in the mode, we see the power consumptions at this moment. We have, and this is only an example, 247.7 watts or 252.3 volt amperes, and a power factor of 0.98. These are gonna be the key measurements for the power consumption we're gonna do for all the light fixtures in our measurement series. All light measurements are gonna be done with the UPR Tech Par 200, which you can see here. This is our quantum spectrometer, a light measurement tool, which I can turn on for you here on the side. After it's turned on, it makes its own dark calibration, which is happening right now. And after it's finished with the dark calibration, you can turn it around and open up the field with the light sensors. This is the actual light sensor, the little white circle you can see here. And this is going to do the measurements in our grid inside the Homebox tent. We will fill the results of the 144 measurements from our Par 200 into an Excel file, which in the end gives us the lighting plot, the example I've shown you before. And these lighting plots will show us the distribution inside the real life grow environment, our Homebox tent. And so we're going to have the same lighting plot in the end for all the different fixtures, which gives you guys the possibility to compare them to each other. Aloha.